one of the good things about Mastercam, of many, is that it makes making fixtures easy. This is a picture of a fixture that we're going to make with the part where it's going to go on the fixture. I'm going to drill and tap holes in the corners. Then I'm going to drill and ring dowel holes here. Then this green thing is a tram hole, or a sweeping hole to set the origin. And those numbers there are its relation to true zero. So we're going to sweep this hole and then move the origin down an inch, and then we'll be able to run parts on top of the fixture. Here is what the finished product looks like. And now I'm going to go over here and run the second part. Set up in the vise like that at full speed. And there it is. The Tutorial 8 high-speed tooling, high-speed toolpath fixture. All right, we have single block off. Rapids are at 100%, and we go. Face this off in the non-zigzag style. It's just making one-way passes that overlap a little bit. That is a 3-inch face mill. Don't need it cooled, really. This gets clear of the part, and the next tool, half-inch spot drill. I'm going to spot drill all the holes. Really don't need coolant for that either. Two-second pause to allow the chips to clear. When it gets down to the bottom of the drill depth, it pauses for 2 seconds. Drill counter bore cycle. Now it's going to do chip break. So the tool does not retract. It just goes down about 100 thousandths and breaks the chip, and then comes back out. When you have thin material, that's nice. So now I'm going to turn the coolant on because I think that needs it. Alright, that's tap drilling for a 1/4-20 tap drill. This is a 10-tool job. So even though it's a relatively simple part, it does have 10 tools to make it. So it took a while to program it, but so now it's tapping those holes. I'm only going about 0.3 deep with a 1/4 tap. And I'll finish them off by hand. The CNC mills are famous for breaking taps. Now this is pilot drilling for the dowel holes. That's PEC drilling. I forgot to change the cycle to chip break. But that shows you the difference between them. PEC drill pulls all the way out of the hole, and chip break stays in it and just breaks the chip. Now it's going to ream. Barely touching, it reams on the way down and then on the way up. That's a 251 reamer, so it reams it a little oversized. I like a little clearance on those dowel holes. Make things easier to load different parts. Okay. Now we're going to tap drill these 3 holes and pilot drill the tram hole. Let's just watch this. That is also a chip break. See? Goes down a little bit, bump, bump, bump. Gonna do the last 2. Turned off the boom. Just watch it there. Right. Now it's going to tap those holes a ½ inch deep with no coolant. Just to pilot start them. I will finish them by hand. Now this is the contour ramp. 1/4 inch end mill. Turn the coolant off. See how it curls its way down. Then it's going to come back up and take a much bigger cut. We need more feed. Goes down 100,000. All the way through the part. Does a finished pass. And then one more finished pass all the way around with a little bit of overlap to precision size that hole. Now we're just writing on engraving the offset numbers or the offset values for how far we have to offset the part. Just using a little bitty 1/8 center drill. The letters don't have to be anything fancy. X is going to be at 0 and Y is going to be at +1 from where it needs to be. So the students will have to remember to offset the origin from here back an inch to this place to find the true corner of the part. Left here in Mastercam. The true offset, the true corner on their parts is going to be here. We need that so that we can set up on the fixture plate and then put our part over the top of it. So that's how you use Mastercam to make a fixture.